Okay, today we're going to go over two vocabulary words, domain and range, but the main goal is to tell whether a chart, diagram, or graph is a function. Okay, first a function. Yeah, function is a set of points where each x value corresponds to exactly one and only one y value. So each x is going to be corresponding to only one y value. Okay, so here's the first example of a function. The x values are on the left, the y values are on the right. Okay, each x value only goes to one number on the right. So the 1 goes to the 8, the 3 goes to the 3, the 6 goes to the 1. Okay, so this is a function because each x has only one y. Okay, the domain, by the way, the domain is the set of x values. Okay, so here the domain would be 1, 3, and 6. The range, it's the set of y values. So here the range would be 3, 8, and 1. Okay, so the way I think of functions, I think of the x as being people. All right, so we have 3 different people. Their names are 1, 3, and 6. And I think of the y values as being birthdays. Okay, so person 1 was born on the 8th of whatever month. Person 3 was born on the 3rd, and person 6 was also born on the 3rd. Can we have this situation? Can we have 2 different people that have the same birthday? Sure we can. So this is a function. It's possible that 2 different people were born on the same day. They can have the same birthday. So if you have a situation like this is a function. Okay, let's compare it to this one. So here, person 1 goes to 3 and 8. They have 2 different birthdays. Could they be born on the 3rd and the 8th? No. One person can't be born on 2 different days. Okay, so this one is not a function because the 1 has 2 different y values. Okay, so the 1 has 2 different y values. Okay, I could connect this 6 to something else if I want. Say the 6 goes to the 1, but this one is the important piece. That one person is split into 2 birthdays. That can't happen. That's not a function. And remember, the domain would be these x values. The range would be these y values. Okay, let's look at 2 more of these diagrams together. Okay, so person 1 was born on the 3rd, person 3 was born on the 1st, and person 6 was born on the 8th. Is this a function? Yes. Each x value has only one y value. Each person has only one birthday. Each x has one y. Next diagram, is this one a function? Okay, person 1 was born on the 3rd, that's fine. Person 6, though, person 6 has 2 different birthdays. Okay, I don't mean this 3 to confuse you. This 3 has nothing to do with it. All right. The 6 is split into 2 different birthdays. Can you have one person with 2 different birthdays? No. Okay, so the problem here is the 6 has 2 y values. Okay, so try to answer this one. Is it a function? And give me a reason why. Okay, so this person has 1 birthday, this person has 1 birthday, and this person has 1 birthday. So yes, it's a function. Each x corresponds to only one y. Oops. each x has one y. Okay, so those are diagrams. Sometimes they'll give you the problem, though, as a set of points. Okay, so remember when you have a set of points, the first number is the x and the second number is the y. Okay, so we can make a diagram out of this. 1 would be mapped to 2, because that's my first point. 3 is the x, 5 is the y. So 3 would be mapped to 5. And 5 would be mapped to 9. So is this a function? Yes, this is fine. Each x has only one y. Each person has only one birthday. Okay, let's look at another set of points. Okay, so x is 1, y is 2. So 1 would map to 2. When x is 3, y is 5. So 3 would map to 5. X is 3 again. So I'm going to have another thing coming out of that 3. 3 is also mapped to 9. Okay, so person 1 is okay. They have one birthday. Person 2 is split. Can a person be born on 2 different days? Nope. This is not a function. 3 has 2 different y values. Okay, you may get even a situation where this is split between even more than 2 things, 3 or 4 things. Okay, but if it's split, if a person has more than one birthday, it's not a function. All right, so x's and y's. 1 is mapped to 2. 3 is mapped to 5. And 4 is also mapped to 5. Okay, so person 1 was born on the 2nd. Person 3 was born on the 5th. Person 4 was also born on the 5th. Is this okay? Is this a function? Yes, this is still a function. Okay. People can share the same birthday. Each person has only one birthday. Each x has one y. Okay, please try this one. Okay, looking at this mapping diagram, each x has one y. This is okay, so yes, this is a function. Okay, let's look at a table of values. Okay, so this table of values we can set up the same way. We can set it up with a mapping diagram. So 1 would map to 3. 2 would map to 5. And 5 would map to 8. Is this a function? Yeah, each x has only one y, so yes, this is a function. Okay, here 1 is mapped to 3. 3 is also mapped to 3. And 4 is mapped to 9. Is this one a function? The answer here is still yes. Each person has one birthday. Even though these two people share the same day, that's okay. Each x has one y. Okay, 4 is mapped to 3. 9 will be mapped to 2. 1 will be mapped to 0. And 4 will be mapped to 1. So 4 is mapped to 1. Is this one a function? Okay, this time the answer is no, because that x is split between 2 different y's. One person has 2 different birthdays. That cannot happen. Please try this one. And this one, the 5 is split. The x value has 2 different y values, so this is not a function. Okay, so the last thing to look at is graphs. Okay, now for a graph, you can do something called the vertical line test. Okay, what a vertical line test is you draw a bunch of vertical lines. Okay, vertical lines are lines that go up and down. If your vertical line hits the graph, let's say this is the graph, if it hits it more than once, then it's not a function. Okay, so let's write that down. If a vertical line can hit your graph more than once, then it's not a function. Okay, so here is the graph. You're not looking at the x and the y axis, you're looking at the graph. So let me draw a vertical line, and I'm going to see if I can find a spot where that hits my graph more than once. Okay, so right now it's not hitting my graph at all. Here it hits my graph once, but if I move over a little bit more, this hits the graph now twice. So this is not a function. Okay, if you want, you can draw like a bunch of vertical lines and just see if any of them hit the graph more than once. All right, let's look at B. So I'll draw a vertical line, and I'm going to see if there's any spot where that hits my graph more than once. Sorry, let me outline the graph. So the graph now is this circle. Here it hits it once, but anywhere else, here, it would hit it twice. So if you can find any spot where it hits a graph twice, then it's not a function. Okay, and the reason is because this x value right here, let's say this x was -3, it has two different y values. It has one up there, let's say it's 9, and one down there, let's say it's -9. Okay, so that x right there, same thing over here. This x value has two different y values. It hits up there and up here. So our diagram would be like this. Whichever the x value, let's say it's -3, it hits the graph at 9, and it hits the graph at -9. So that's why it's not a function. Okay, C, here's my graph. If I can find a vertical line, and if it hits my graph more than once, okay, if I draw that vertical line right there, that hits the graph a bunch of times, right? Hits it everywhere. So that is not a function. So it has to be this last one. Okay, so if I draw a vertical line, here's the graph. Is there anywhere where that vertical line will hit the graph more than once? There it would hit once, only hit once, only hit once, only hit once. So this one is the function, because that vertical line only hits the graph one time. Okay, let's look at 3 of these and then you'll try one. Which diagram is not the graph of a function? Okay, so let's do our vertical line test. Let me draw them all, and then we'll drag them into each graph. Okay, so you can't drag on your paper, so you would draw the vertical line on the graph. Okay, so this first one, can I find a spot where it hits the graph more than once? Yeah, I can find a bunch of spots. Okay, so again, my graph is the oval here. Can I find a spot where it hits it more than once? Sure. So that one is going to be your answer. That one's not the function. Okay, let's just double check. So this one would hit the graph only once on this side. Nope, that's a function. This hits the graph one time. Remember, this curve is the graph. You're not looking at the axes. You're looking at the graph. So that hits only once, and this vertical line would hit that graph only once. Which diagram shows a relation that is not a function? Okay, so we're going to do the vertical line test for graphs to see if any of these x's has two different y's. Yep, that's definitely the one that's not a function. That hits the graph 1, 2, 3, 4 times in that one spot. So that one's not a function. Okay, this one would hit that curve only once. Same with this curve. If I move that line over, it's going to hit that curve only once. Okay, this one's a little tricky. Okay, so here it would hit that function, that green line, only once. You might think the middle part, okay, but you see how those middle circles are open? It means the function doesn't exist there. Okay, so anywhere where you draw that vertical line, it would hit once. So all of these are functions. Your answer there was A. Which graph is a function? So this one you want to find one that is a function. A, I can draw a vertical line that hits that more than once. That's not a function. C, I could find a line that hits that more than once. D, I could find a line that hits that more than once. Okay, so the answer is B. If I draw a vertical line, it would only hit that function one time. Okay, please try this one. And the answer to there was A. And the other ones, if you could find a spot that it hits it more than once, the answer is no. Okay, I know you may be able to find a spot where it does just hit it once, like right there, but that's not important. You gotta try to find a spot where it hits it more than once.